All right, let's do this. Goodbye, JavaScript for now.
So if you all follow me on Twitter, you might have seen me posting a lot more charts and graphs about memory usage. And the reason I'm kind of getting into that rabbit hole is because I noticed a lot of my Next.js applications.
By the way, I forgot to turn off alerts. So, professional streamer, let's go.
Just start eating up memory over time. And I think a lot of this is because of the image optimization with Sharp, but it kind of just got me thinking of like, should we be trying to achieve more in this industry by using less? And by less, I mean like less code, less dependencies, less complexity. Now, I will say a lot of the stuff I do at work.
By the way, that is absolutely based take. Just fantastic. And this is a ton of memory, by the way. Just think about how much actual memory that is. You're serving some requests. You know, we don't know what's going on, but 400 megabytes, like that's so much stuff. It's just so much stuff when you really think about it. Because whenever you build an application that uses, you know, when you actually have to use memory, it always is just like 1/8 the size. And you're just like, what am I doing? It's just wild to think about that.
Work is related to AWS and cloud computing. We do like serverless, DynamoDB, Dynamo Streams to Elasticsearch, infrastructure as code with Terraform. And it's like the complexity sometimes starts to get so much greater than the actual thing you're trying to deploy out to production, right? Which kind of reminded me of this ideology of like, can we achieve more? Either that's like more performance, more features, more whatever, by doing less or writing less or depending on less.
We used to have this phrase at Netflix that if you want something to be more performant, stop doing so much. It's the easiest way to get better performance is you don't. That's the answer. Because we actually had a memory problem. We had to constantly take out libraries. I can't tell you how many times I had to remove a library. Core.js, it's just amazing how much memory that thing can use. Lodash, it's incredible how much memory you can use. Right? It's incredible how much memory is being used by some of these things. It's wild. And the best part is that you use like one or two functions from Lodash. And they're simple. They're simple, right? They're so simple. What function do you use? Someone says, man, I love Lodash. What do you use? What do you use from Lodash? Key shooter, tell me. I gotta know this. I actually use the whole, I know, okay, tell me your favorite function. Give me 3 functions you use. Dude, debounce and throttle. Dude, most of you are using simple debounce. Most of you are using simple. Yeah, name 3 songs. Dude, I am. I just want to know. Ramda, dude, it's crazy. People that use Ramda are people that want to make a code base only usable by them. Oh, see, you don't use it anymore because you don't need to use it anymore. I knew it. I could feel it, and I knew it. I could feel it deep down. I knew it. I knew they're lying to me, Karen. I just knew. I could just feel it. I could feel it deep down in my bones, and I called them out. I was just like, hey, you step up. Couldn't do it. Couldn't deliver, Karen. We got him.
So here's Icon Generator. This is like one of my first real applications I deployed with Next.js that actually gets me, I think, $1,000 a month from revenue, which is pretty nice.
Oh, nice job.
But you can see here it's hovering around like 400 megabytes of usage, which kind of seems like a lot of usage. Maybe there's a bunch of caching going on behind the scenes, which is why it's like so high. But I was seeing kind of similar performance with other things I was deploying, right? So for example, here's another application that I used to have in Next.js. It's like one page, and I was inspecting the memory usage, which I don't think I have it anymore with the Next.js version, but we can look at something else that's also one page, my WDC starter kit, okay? This used to be in Next.js as well. And at times I saw it go all the way up to like 300, 400 megabytes of memory. And it just kind of got me thinking of like, why is it that a single static page needs so much memory? Because it really shouldn't. And so what I did is I refactored.
You know, I love this arc. I think every developer needs to go through this arc. Honestly, you do need to go through this arc where you go, why am I using this much? Like, what I'm producing is simple. Why am I doing this? And like the thing is if you end up going back and you go back to doing all of this nonsense, right? You go back to using Next.js to generate a simple static website, and you're using a gajillion megabytes of memory. I don't blame you, okay? I'm not saying that you're a horrible developer. I'm just saying if you've never gone down that road, if you've never even thought about this idea that why am I using so much? Like, it's such a useful journey to go down. It's so useful to actually try to figure out what the hell's even happening. Because if you look at the CPU, like, you're not even doing anything. You're not even like doing a single thing. Like, so why are you using this much? What's happening? You should ask yourself, you should try different versions of languages and servers and see how this actually changes and see if you actually have, like, if you have a better experience, because you might just find out that you actually have a significant better experience in a different language. And you go, oh, wow, I actually really like this. I would have never known, but I'm glad that I tried this. And maybe you hate it, and that's fine. You hate it. You go back to PHP or whatever the hell you're programming, and your microplastics are right back in your balls. But you at least enjoy the experience of doing something different for a while.
Factored the starter kit to instead use Hona, and then also I have another application that I kind of worked on. This used to be in Next.js as well. Saw the same things where like the memory usage just kept getting higher. I refactored this to use Hona and Bun. Okay, so let's kind of look at the difference, right? So
the funny thing is that Hana and Bun, it's not even like it's that far different, right? You're still using JavaScript, which means you're going to be using JSC instead of V8. JSC still has a bunch of JIT information that it holds on to. You're still going to have a whole bunch of You're still going to have a whole bunch of just memory being used by everything. It's just the way JavaScript works. Like, if you use V8 and you inspect it with the performance tab, or not the performance tab, but the memory tab, and you start looking into functions, you'll see it like a lot of your functions just have 30K worth of optimization data just on every one of your functions, right? It just is what it is. You know, that's just JavaScript. That's what makes it attempting to be fast.
So this is now hovering about 150. What you're looking at right here is the Hona implementation.
Yeah.
I'm pretty sure. And if we go over to Knowles Glass with Node, let's look at the memory usage of this, hovering around 105. Granted, there's not much traffic hitting this site at all, but this is better. It's not great. I mean, I still think this is quite a lot of memory usage for a single application with very, very little traffic. Here's Bun. You can see that when I first deploy it, it's like 44 megs. And then again, that just slowly starts climbing and climbing and climbing. And then I did the deployment. That went back down to something lower, and then it starts climbing and climbing and climbing. And granted, in the grand scheme of things, like Railway only charges you like not that much money for like memory usage. But overall, when I have like this many projects deployed out and all of them slowly start creeping up in memory usage, either because it's like a garbage collection issue or there's memory leaks inside of Next.js or inside of the services. I don't know if Bun's production ready or not. It just got me thinking of like, why not just do something else? Why not just use Go? Use Rust?
By the way, JSC typically found it to be better for embedded. It just tends to use less memory, especially if you have you can control like the garbage collection rate on it. But this is crazy. 400 megabytes to 100 something. Like that is, it's rather wild, right? It's rather wild. JavaScript eating the world's memory.
Rust. Use C. If this is the state with JavaScript, like why not just use something that's actually like performant from out of the box? So some of the investigation I've been kind of looking into is using Go. Go is another thing that I've used on my channel a couple times. I kind of just played around with it, but
nice
now
language.
I'm at the point where I actually might go more all in on Go at this point. Now, granted, I just released a starter kit that uses Next.js, and I still think Next.js is a great way of like, you're a solopreneur or small team, you just need to get something out there. Yeah, you can move very, very fast with Next.js. And I would still probably, if someone came to me and said, hey, I need something built, I would probably use Next.js. But in the grand scheme of things, I think we need to have a philosophy or a mindset change a little bit and try to achieve more with less. So let's look at the project that I refound.
By the way, I think this is one thing that's really amazing about the game industry is often you don't have a choice. You actually have to like use less. You're kind of forced down this route of attempting to use less and less and less. And you must make room for other parts of the game system. So it actually like it makes you adopt this mentality where lines of code matter. Like something that was really interesting when I was working with a bunch of C++ devs is that every time I wrote a line of code, and even though it used another few bytes, like it wasn't even big amounts of bytes, they'd go, whoa, 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 we can't use that. You're creating memory for no need. Don't do that. Right? Like their mentality was just so much different than my mentality. And it's because I kind of, I ended up spending so much time in this JavaScript world, I kind of just forgot, right? I just forgot about why people did stuff. But instead, it's just their mentality is so different, which is, why are you creating that? Oh, hey, don't do that. Don't create that. Use this. Oh, wait, you're doing this. Hey, do this, right? And it's just like, it was just such a different mentality. And even though it resulted in bytes being saved, maybe even a kilobyte being saved, it's just such a different hat to wear. Let's see. And this is what you get for running on embedded systems even more. You have to cut corners to make it fit. Exactly. There's something really kind of cool about that. There's something neat about that process, and I do think it's really good to kind of at least attempt that mentality from time to time.
Factored to Go, and I believe it's called, if I go to the promo site, I have 2 implementations of a mailing list. Okay, so one is in Go and Fiber, and one is in Bun and Hona. So let's look at the Bun and Hona one. If you go over here, this is eating up 150 megabytes of memory for a very, very simple page, where literally I'm seeing this across the board. So maybe this is a Railway issue. Maybe Railway has overhead to your services. But let's look at the Go and Fiber implementation. You're going to be blown away. This is using 11 megabytes of memory. When I first deploy it, it uses 6, and then it goes up to 11 megabytes of memory, which is good because A, how much do I get charged for running a service that's 11 megabytes of memory? I get charged pennies on Railway. Versus Bun and Hona, I'm going to get charged more. Now, secondly, the code between the Go implementation and the Bun implementation is very similar, right? There's like...
I want to pause it for that previous moment. The thing that I think he's making a lot of sense with is that, sure, like if you're just one application running, it's not a big deal, but imagine if you have 50 applications and they're all taking up 400 megabytes. They're all taking up a lot. All of a sudden, your spend is just at the angle is at just a steeper incline. Your MX plus B, your M's just a lot higher. And so it does make sense that as you scale more and more, using something that doesn't cost a whole lot makes a lot of sense. And for those that have never actually used a language like this or understand why this is, let me just give you kind of a very simple explanation for why this happens. So in Go and in JavaScript, you can pretty much create the same thing. You can do an object of some amount, and it can have some keys, and it can have some values. Now, let's just pretend these are also objects, arrays, strings. There's something, right? In Go and in JavaScript, they're both garbage collected. So it's not like you're getting out of garbage collection. This still exists. You'll get more memory usage, less memory usage, more memory usage, less memory usage. But the difference is that if you have a struct with a couple properties, you actually will get something that uses that much memory. And then there's going to be a small little handle for the GC to be able to keep track of some extra information. Whereas with JavaScript, it just has to have a whole bunch more information associated with it. It somehow takes up so much more stuff. And why? I'm not actually particularly sure why it takes up more stuff. Second, with Go, you actually have access to the stack. The stack makes things a lot nicer. So if you have a stack allocated struct, it doesn't have to go out and grab all this information. It doesn't have to go and be put into the garbage collection. It doesn't have to go and reserve all of it. Instead, you can have a struct that is just literally 3 ints, and they're all just simply packed nicely. It takes whatever 3 ints would take, 180, 100 and whatever that would be, 64, that'd be 192, right? Take 192 bytes or 192 bits. Whereas if you do the same thing with JavaScript, it can take significantly more because there is no stack in JavaScript. You can get none of those optimizations. You have to use the heap for everything. The only thing that you don't use the heap for, as far as I know, is small integers. Small integers are usually right around 32-bit or smaller integers. Anything like that, it actually uses your heap pointer, and it has a little tag at either the front or the back that says, I'm a heap object or I'm an integer. And if it does that, then the rest of it is going to be your integer. All right, like that's its big memory optimization. So there you go. There's kind of like the basics. I've never really understood why it needs to use so much more memory than Go. Especially when Go allocates the same struct on the heap as JavaScript does. It just somehow uses so much more memory. So I'm sure it's just a bunch of more boxes that are going on. So every single one of your fields ends up being a box in itself. And so therefore you just have, instead of something costing, say, 32 bits or 64 bits, it ends up costing, just a giant amount. It costs 1K worth of data just because of how much extra information it needs to have. And so then you get that distributed through every last one of your items. How'd you all come up at this point of knowledge? Just looking at things. So the JS node time or the JS runtime does use just a lot of memory to store the same amount of stuff. This sounds ridiculous as a C++ programmer. It should sound ridiculous as a C++ programmer. I mean, that's one reason why I've really just enjoyed using Zig, because it's just like whenever I allocate something, I know exactly what I'm allocating. I'm like, I make this much memory and I let go of this much memory. And that's it. Like there's no, I don't have to try to imagine how much memory are you actually using, which is a very hard thing to work through in your brain. To play this game of let's reduce memory of a JavaScript application is really hard because you don't actually know how much memory things use. And Go is just a way more efficient version of it. And the nice part about Go, another thing that makes Go way more memory efficient that I forgot to mention, is that when you're using JavaScript, every single function could be JITted. And just-in-time compilation, right? And that requires a bunch of information to be stored. Whereas Go, it's compiled. It already does all the optimizations it needs to do, and then it just runs. So it doesn't have to keep track of any of that extra information. So all the stuff that needs to be kept around for a whole bunch of time does not need to happen. It already did the optimization, which is why some people are always talking about why WASM is going to be really good, is because you can do all of this. You can do all of this ahead of time.
It's almost like the same code, just written in different syntax. And so if you are trying to get more performance by writing the same code, why wouldn't you just do that? Okay, so that's kind of like what I'm doing here. And yeah, I mean, it's great. Now, you can even get this lower. People keep saying that I should be using the standard library in Go instead of Fiber. But the point is you're able to achieve this type of performance in this low memory usage out of the box with not even having to thinking about caching. I'm not caching anything. I don't even have to think about CDN or caching or any optimizations. This literally just doesn't use memory on your machine. But let's be honest, I think the Go implementation could probably serve a lot more requests per second than anything in the Node or JavaScript ecosystem. So now...
Yes, that's also true. You kind of get a double win. You use less memory and you can serve... I did a few experiments, and I'm sure you've seen it, with a game. I've built some games where I do a shooter. It simulates a shooting game and does all this, and I did it in Node, Rust, and Go. And it's just, the difference between Node and Go, it wasn't something along the lines of oh, well, here's Node, it's that bad, and here's Go, it's this. It's just a little bit better. The difference was literally here's Node, here's Go. It is a universe difference. And the difficulty of writing it is not much more, right? It's not like I struggled with one versus the other. I was deeply less familiar with Go than I was with JavaScript, and it was as fast, if not faster, to build it. And the Rust one was even lower. But the difference between the Rust one and the Go one is not huge comparatively to the difference between a JavaScript and Go. Because that difference is just so big because you're going from one language type to a different language type. And also the whole idea of just using the standard library versus Fiber, I'm sure there's some things with Fiber, right? Middleware, all that stuff that just makes life a little bit easier. Versus the standard library, I believe all you get with standard library is routing. And they've now recently added in some of the newer versions of Go, some basic pathing to be able to do some, the colon ID and to be able to bring out, URL parsing really easy.
Now that I have you hooked.
But I do want to say one quick thing though. The amount of engineering effort that has gone in to make Node usable is amazing, and being able to build something that is fully functioning as quick and as simple, JavaScript really does do a great job. People have put in literally $1 billion to make Next.js or whatever it is actually work. It's pretty impressive how much you get out of the box.
Hooked with this very obvious argument of why you should probably just use Go. I mean, look at this. I'll even zoom in for you. Look how nice that is, 6 megabytes. The other argument for Go
That's like
is that
40x difference.
you can basically achieve a fully functioning REST API.
No, hey, first off, it's not that I love. Hey, I'm just recognizing the simple. Okay, if you want to get something up that has image caching, that has, you get all the crap you want, it is shocking how easy it actually is. Like the hard part is that I've been doing this for so long. I remember back in the day trying to launch stuff with Apache and PHP and MySQL and the Lamb stack, using XAMPP to test on Windows and all that kind of crap. And oh my gosh, right? It was really hard back in my day. I'm just saying, why are you guys doing that? That's obvious for most of us. I'm just saying it's so simple. But at the same time, I would not. XAMPP was great. XAMPP was great. I just wouldn't want to use it because I know that its simplicity is seducing. It's insidious, assuming that it's easy, because I think the complexity of it ends up being worse as you get beyond anything trivial. You describe my current job: Cold Fusion, PHP, Perl, JS. Oh man, Cold Fusion. Please, can we just get that word banned?
Guy with bringing in no external dependencies. Okay, you can just use the things that are built into the Go standard library and build out a REST API. Now, granted, with Bun and Hona, I mean, you don't have that many dependencies, but again, you're like depending on Bun, which in my opinion, it's too early to like really adopt it. I'm sure it has like underlying issues, and honestly, I think it just needs more time to cook. I would probably still use Node on.
Was that a bun? Was that a bun joke? Was that a bun joke? Bun needs more time to cook. A little raw. By the way, how much dependencies does Hona have? Hona JS. What are we talking about? What are we talking about? Let's see this thing. Let's go to the package.json. Let's see what we got here. Okay, we got a lot of scripts. We got a lot of exports. Don't you love the fact? Isn't this just such a lovely day in JavaScript that you get to do this? Isn't that just so great? Don't you love a language that you have to do this with? Just so delicious. Just absolutely wonderful. Let me just go through all of this crap. All right. Okay, gosh. Here. What am I doing here? What the hell am I doing here? Here. Do I have JQ on this machine? I do. Yes. Let's go. I can go JQ dependencies out. Is there no dependencies? Dev dependencies. Am I spelling that wrong? Okay, there's a whole bunch of dev dependencies, but they're saying there's no dependencies. Well, like I totally get some of these things, like ESBuild and ESLint. That makes sense. But what is things like WebSockets and Zod doing? I'm curious how this thing works. Do I not understand? Dev dependencies. So there's a lot of dev dependencies. I guess there's no dependencies. Okay. Well, hey, I guess it's better. Hey, let's go. There we go. Hano doing good. Build everything out themselves.
On anything serious, but on side projects, you just want it to be fast. Yeah, I mean, probably use Bun and Hona. But again, like, look at this comparison. You might not care, and I think that's the point I'm trying to drive at, is you should care. The same amount of code in terms of developer experience. In fact, I think Go actually has a really good developer experience. Like, you literally can just like save a file. It auto formats for you automatically. You don't have to install Prettier. Again, doing more with less. It's
by the way, not only not installing Prettier, but this entire argument and ecosystem around styling and everything, and the amount of like I always just think about null ls and the fact that they tried to build something that runs by linting and formatting a library for you, and they gave up and they quit because it is such an awful ecosystem when it comes to linting and formatting for all these different languages. And Go and Rust and some of the new modern ones, I believe even Zig too, all just does it. They all have just formatting as part of their LSP. Go's worst thing is package management. That is not true at all. Their package management is just it's literally it is perfectly it's no different than NPM at this point. You just go get in fact, I would argue that it's nicer in the sense that you can do packages from any Git endpoint. You can do it with GitLab. You can do things from GitHub. It's very, very nice. Go mod tidy just works, right? the argument that it's not good, I just don't buy nearly as much. Now, you could have said Go package management was bad, which is true. It's very, very true. Go at one point was actually really, really bad, but now it's not nearly as bad. Really hard to work with private repos and Docker with Go. Can the same to be said with NPM? Because I assume whatever is going on with Go and private repos is the exact same problem with NPM. You have your installing program or your fetching program unable to fetch because it's missing the credentials. Go private exists. See, I don't know. I assume that. I use private repos every day. Hell yeah, let's go. Yeah, very hard to configure credentials. Yeah, that sounds like a credentialing problem more than anything else. NPM registry with Go, you need to get access /SSH. Yeah, okay, but NPM again, you're saying public versus private. And if you're using private, you have to have NPM credentials, or you have to have an NPM like Artifactory that's hosted internally on your network, which then I would argue you could have a stash or some sort of Git private hosting that would be equal, right? Like you're not actually changing anything there. The argument I don't think makes I'm not quite understanding the argument, because it sounds like either you have private hosting, which is hard and takes like a team, or you have public hosting, which is not hard, but it's not like private NPM. Whatever you have with Go will be the same with JavaScript, because it's all using some sort of private thing, whether it's internally hosted or you're paying for some sort of service, right? I would love to see people complain about Go Package Manager trying to use Zig Package Manager. Yeah, that I haven't used it yet. And by the way, right now my zigging is no dependency zig. Oh, I need HTTP, building it myself. I know they have HTTP. Calm down.
Built into the Go standard library, like format stuff for you already. Bringing in these packages, you don't have to like right click on anything and say import. Go will just automatically import stuff when you save files. Some things that are built into the box that you're not going to have with Next.js is channels. Yeah. So if you have used Node, you'll notice that if you have a longer running thing that really eats into CPU time, it's going to block the entire thread in Node.js. So if you imagine you have like a for loop inside like a backend endpoint that does like 1 million records, that has to loop through 1 million records, you're potentially going to block every single request from hitting your Node API. Is that something that you actually want to think about? Probably not, right? With Go, you have channels, and channels basically spin things up and run them in their own threads. Now, I do think it's more nuanced to that, but everything runs in its own thread, so you don't have to worry about like me blocking the entire thread for every API request, because you have these constructs that are built directly into Go that allow you to just like push things into a channel and process them.
By the way, someone's saying workers, like you just can't tell me workers are this easy, right? You can't. This is not, it's just not the same, right? Like workers are not easy. For anyone that has used workers, know that they suck and they're awful. This is just so straightforward, right? It's like, I need to be able to run potentially on a different thread, right? Like if you're on a single core CPU, you obviously will get concurrency, but you will not get parallelism at all. Fair and factual. But nonetheless, this right here is absolutely absurd to say that this is somehow just as easy as workers, because it's not. This is tremendously easier. This is categorically easier comparatively. Dude, just use Java. You know, I don't want to use Java. Let's see. Workers sound great. But when you start working with them, the skill issuing there is next level. There is a lot of skill issues with workers, but there's also a lot of skill issues with funks, right? Or Go funks. People don't realize this, but there's a lot of problems that do exist, and it does take a little bit of getting used to. It's most certainly not free. Obviously, I heard someone in here saying, hey, make sure you actually close your channels. They are true. This ticker.stop closes the channel, which is very, very nice. You know, you can see some of these things. You got to make sure that you're actually doing it right. There's a lot to it that makes it a little bit difficulty. Concurrency is always hard, no matter how you do it. And parallelism is just even harder.
Now, granted, stuff like PHP Laravel has like queues built in, which I think achieves something similar. Elixir and Erlang is also really great with that type of stuff. Another thing I want to show you is if you've ever deployed Node.js to production, in particular to like serverless, most of the times they're bringing in like ES build so they can bundle your Node application, like actually bundle your API code and get that deployed out so it's not as large. So again, you're bringing in more external things that are not baked into JavaScript or TypeScript itself, just so that you can get this stuff running on AWS, which I think is a code smell. I think it's a smell with the design of the ecosystem with TypeScript, with JavaScript. And instead, let me just show you.
By the way, I will say it's unfair to call it a smell because that is as designed. The smell is the fact that you're trying to run a language that was intended to run in a very specific environment in a different environment. Like that's really the problem. You're just running something that was never designed to run in this place. JavaScript was never designed to run there, so of course you have to jump through hoops. You're creating the browser environment in a way that allows this all to happen. Also, what the hell is this run command being indented like that? Do you want a fist fight? We are fist fighting. Just saying.
You this Docker file, okay? I have this Docker file which runs through. It builds up this Go binary, and again, when Go finishes running, it just gives you one single binary with all the code that's necessary inside of that binary. Okay, so with this multi-stage...
And Go is largely just like a self-contained binary too, correct? Do I have that correct? You don't have all the fun linking problems that you do. Like one of Go's biggest features is that it's very easy to cross-compile and just have it run wherever you target the build to. Whereas Rust is still very difficult. Various platforms are very difficult. Unless if you use CGO, but that's fair, right? I don't like again. I haven't ever built a binary myself, so I know it's called statically linked, but I don't really know what that means, right? Because I've never built it myself, so I still just have this like box in my head that says it makes life easy, but I don't know what that means. I just assumed everything is self-contained in one box, and when you use a function, it just actually hops over, right? I haven't actually built it myself. It's pretty easy to cross-compile to almost anything. Yeah, as far as I can tell, Go makes it pretty straightforward for a lot of these things. Yeah, statically linked means the libs are all copied into the binary. See, that's what I thought. I just didn't know how to... I don't know what that looks like. I just assumed the offsets just offset within the binary. The binary is still quite large. This is true. The binary is still quite large, but that's the cost of a statically linked one, right? You actually compile everything together, which I would say is... It makes it very nice for cross-compiling. Technically, you can cross-compile C. That's true. But you know what's really fun to cross-compile C with? Is when you cross-compile C and Windows treats a file descriptor or a socket as a class and Unix treats it as a file descriptor. So instead you get this just like really fun if-def code in C just to make an effing socket work. It's just so much fun. You know what I'm talking about, how fun it is to write a basic TCP, like your own little simple structured like sending algorithm. I know, back to Segwin. That's it, back to Segwin.
Docker file. I build a Go binary, and I also have like my public assets. And then I create a
Temple.
Docker image from scratch.
Sorry for interrupting one more time. Sorry for all the pausing, but Temple, super cool library. And the guy who created Temple, super cool. I think he shockingly just one of the most like humble, nicest devs I have met in a long time. Guy's clearly a genius. Temple OS, not Temple TMPL. Just absolutely, just a W. Just an absolute W. Pragma balls.
Scratch, if you don't know what the Scratch is basically an image that has nothing on it. So it's like 0 bytes. It's super small, super performant. And so I can just grab that node binary and my public assets and put them in this empty Docker image and then run that binary. And at the end of this, like when you actually build this, we're talking like maybe a
He said node binary, but he meant Go.
Megabyte or less of how big this image is because it only contains those two things. Which is nice because this is literally built into Go. It compiles your code into a single executable, which in Node.js, like I'm just tired of like having to deal with ES-build. I'm tired of dealing with Webpack. And then at some point it was using like Snowbuild or Snowpack. And then we started using...
Oh, did Fred just catch a stray? Did Fred Scott of Snowpack just catch a stray? Let's go, Fred. He is absolutely right. When I started in the JavaScript world, I had to build my own bundler, and I built it in Java using Google Closure Compiler. Then Grunt came out, and I converted everything to Grunt. And then from Grunt, Gulp came out. And then after Gulp came Webpack. And then came Hellpack, which is just all the different bundlers that all do the different things. And you can do all these different nice ways. And second, you know what? While we're here, you know what? I'm going to say something. I'm saying something, and people, you're going to sit down and shut the hell up because I'm going to say something that's going to hurt a lot of you. Mono repos are people who complain about clean code and then make a more disastrous architecture. You know why? You literally have like 3 packages in your mono repo that are each like 100 lines of code, and you go into this version craziness with all this infrastructure when you could have made it into a single effing file and called it a day. Okay, stop. Stop pretending that it's going to be this big, gigantic project. Break it up when you actually need to break it up. This idea of starting with a mono repo for hundreds of lines of code is just insane. You are worse than clean architecture. You are the lowest possible form of architecture. You're clean, dirty architecture, or whatever it's called. I don't even know what it is, but it's awful. Just start with an effing repo and start with one file. Okay? And when you need to expand, okay? Ridiculous. Absolutely gosh dang ridiculous, okay? Just makes me disappointed. Isn't breaking up a project super hard when the project got big? Well, it depends, right? That's the thing, is I don't think it's all that crazy, because here's the deal. When you're first starting off on a project, the versions, they change like wild, right? You're like 01 420, right? It's just burning up this thing, going super, super fast. And then at some point, it actually stabilizes these little teeny libraries that are developing inside your app. Because what people don't understand is that your app, as time moves forward, becomes thinner and thinner and thinner, and your library code becomes bigger and bigger and bigger. That's just what happens. And so splitting this thing off becomes a lot easier. It can just simply become its own repo if you need it to be. You don't have to have it as a mono repo because its changes start going down. If you have parts of your library that are changing nonstop, to me, that is a code smell. Something has gone wrong. Something is going wrong if your libraries are constantly changing all the time. And so as these things start to stabilize, which they will, they'll eventually start stabilizing. Just being able to pull something out and just having it as a dependency is just so much nicer than these mono repos. I cannot tell you how many problems I've run into mono repos. They start nice. They always start nice. There's all these ways to do it. Everything's great. And then you eventually get these little things. You just spend so much effing time on a build system to make it right. And I know, I hear you guys. There's going to be people in here that are like, mono repos are the greatest. I know. I've been there. I had parts where I enjoyed it. It's just not that great. To be frank, mono repos are useful with apps with shared UI component libs. No, you just have a lib. The lib can be pulled in. It doesn't have to be shared. I know you think mono repos are wonderful. I don't think they're wonderful. I think most of you just need a repo. Okay? You just need a repo. Use a repo until it gets to the point that it's difficult to manage. At any point that it becomes difficult. Honestly, Ligman Pizza, I think you're actually categorically wrong if you start off with a mono repo. Like, if you start off with a mono repo, I think you're categorically wrong. Until you have any real use case of why you need to be there, don't be there. The amount of time, because the thing is that when I worked on a larger team that had 100 devs on it, as the build process kept going and as the mono repo got bigger, the amount of people, the amount of effort it took to even change something about the build just gets wild. It just blows up. And so it's not a clear trade-off. It is most certainly not. There's not some nice, once you get to a point, 100 devs on a mono repo sounds awful. It is awful. It really is awful. Multiple repos aren't that hard when parts of it doesn't change. And I understand the desire for mono repos. You want to be able to have this section and this section. You want to be able to release them independently. But what are you buying? At what cost? At what cost are you doing that? Because somehow I just feel like if you're constantly coupled together and you're constantly releasing and changing, something tells me that's just one library. I know you don't want it to be that way. The only reason why you'd pull it apart is that you want actually two things to be able to rely on this one library. Okay, I can buy that, but then why in the same area? Like, why are you doing this? Why are you building your dependency graph in your build system? Like directly as your like file library layout. It just feels weird. It just feels weird to me. I've never liked it. Okay, to be fair, when I first saw it, I absolutely fell in love with it. And then I realized it was me who was the problem. I was the problem. I kept trying to solve my versioning problem and immediate abstraction by using a mono repo, whereas instead I should have just had it all together, and when I realized what I needed to split off, I would split it off. Anyways, there you go. Sorry,
like
it happened.
Grunt and gulp. It's just a never-ending cycle of like BS, dare I say, that to basically cover up the smells of the ecosystem, versus I think Go is just designed from the get-go of like, this is good engineering. And by the way, I do want to point out that it has...
I do want to say one thing about Go. Go has several mistakes. If you use Go long enough, you'll find that there's plenty of things that suck. They just do. Go is not great. Go is boring. Go is simple. You can build a lot of stuff in Go. It makes building web apps really simple. Very, very easy. You just get going, you just run. It's true for every language. Of course, that's the thing, is I want to make sure you understand that when you use Go, Go has its own downfalls. And by the way, first off, you're specifying it incorrect. But second off, I do not think error as a value is a fault of Go. And I do not think that the if statements are bad either. Go is ass if you start comparing it to something like Haskell. But if you use it for what it is, it's good enough. Yeah. And I mean, the thing is, if you compare, it goes bi-directionally. If you try to make Haskell like Go, it sucks. If you try to make Go like Haskell, it sucks. It's the same thing, right? Like anytime you try to make a language into something else, it always sucks. Zig error handling feels like a step forward. Zig error handling is very nice, I must say, because it's kind of the best of both worlds. But I do like Go where they make you explicitly handle the error. Like in JavaScript, it's very, very difficult to always know your unhappy path. It's very easy to know your happy path. It's hard to know your unhappy path. Whereas with Go, it's almost like the opposite. It's very easy to know your unhappy path. And so you always program for that the things that can go wrong. And that makes it really, really nice.
Have a Next.js starter kit. If you do still want to use Next.js, even though I've been bashing the entire ecosystem, where I'm basically making videos to walk you through all of the code base of the starter kit. The starter kit is all free MIT. But I do plan to make a bunch of videos to explain this code base.
By the way, this is actually such a good take for those that aren't catching why or confused why he's doing that. This idea of bashing the ecosystem, but also using it a whole bunch and having a starter kit, that means he's speaking from experience. And this is really, really great. I actually love to see this. And it also just shows that even though he doesn't like a lot of the places that it's going, he recognizes how easy it is. There's a lot of good nuance here.
Again, no hate towards Next.js. I have actually made some decent money using Next.js, so I'm not going to write it off. But I just wanted to give that little plug right there, since you're still listening, hopefully. Now, I think another thing that really triggered my mindset change a little bit was HTMX. I know HTMX seems like a meme.
Let's go.
But the more you think about it, like the fact that if you write Go and you can achieve this much performance increase by just switching to Go, you are going to take a hit in terms of your client-side interactivity. And if you end up having to pull in Vue or Svelte or React or Next or whatever to achieve client-side functionality, it just doesn't feel right. Now, one of the things that makes HTMX so appealing, again, is that all of the heavy lifting and power of Go can generate your templates and send them over from the back end to the front end. Now, this isn't new. I mean, we've been doing this forever in the industry. But the idea is that, like, can you achieve more with less? Can you achieve the same or close to the same front-end client-side functionality without having to write any JavaScript at all?
The thing is, you can write JavaScript too. I wrote, Conway's Game of Life with HTMX, and I used the Chrome of Conway's Game of Life to be able to save at any point with HTMX. But the actual thing, I wrote a little component that just did the Conway's Game of Life. You can actually use React plus HTMX. You don't have to choose one or the other. That's the nice part, is you can actually put them together in whatever way you want, which is really, really nice.
And I think HTMX kind of provides that. Now, currently, that's kind of the mindset and ideology I want to kind of follow for a little bit right now. I just want to experiment. Like, can I achieve a nice enough user experience where I still have all the benefits of using Go? I still have all the benefits of showing spinners and interaction and dynamically swapping out things on the page without having to bring in all this bloat that's associated with TypeScript and the JavaScript ecosystem. Now,
by the way, it is true. The less is more mentality is very, very refreshing. It's nice just to see like someone, especially someone like WebDev Cody, who's been a big voice in this industry. I mean, I've known of him for quite some time. He's a very talented video maker and all that. It's very nice to see him go, okay, let's try something different. Because I think this is just, again, I said this at the beginning, I think it's just such a good thing for you to do. And you should just try it once. And I'm going to say something that's probably pretty redonkulous. I do think web components, I know, I can already tell people are getting upset. Web components will last the test of time. The reason being is that a web component is fully self-contained, and it works 2 years ago, it will work today, and it will work in 2 years. They're not fun to write, certainly. They're not great. They're not great experiences, but they actually have like a super long shelf life. If you wrote a web component 5 years ago, and in 5 years you'll still be able to use it, it will be the same. It is one of the best parts about the web. People are trying to make HTMX components. I'm sure you could. I'm sure there's a way you could do that, but the thing is you don't actually really have to make HTMX components. You just make a web component. HTMX does not have this notion of components. All it does is it literally is how you transform the HTML. Is Works Forever really that big of a deal? Have you ever worked on a project that's 10 years old? I think this Works Forever thing becomes increasingly more important the longer your project is around, because having to rewrite things or having to change things when you upgrade a library becomes more and more untenable. And one of these things that happens is that you end up, like this is what happened at Netflix, right? You have a library that you're using, and it's called React. And then at some point, you can't upgrade React anymore because the cost of upgrading React requires so much change in the project that, sure, you could, but you have to spend so much effort and time and human resources, and then you have this feature branch that is just awful, that requires so much rebasing and merging and just so much crap and so many merge conflicts. You end up Roman riding this crazy application. Releasing it is super hard. Like, upgrading a library all of a sudden becomes really difficult. Of course, it starts off really, really simple, right? It starts off nice because you have no legacy. But then once legacy sets in and once the library starts breaking itself, it becomes harder. Please stop. Please, PTSD. I know it is. Dude, upgrading to React 16 was emotionally bruising for a lot of people. And then they made React 18. And now they're on to React 19. Like, think about how many people right now in chat are like, like they're just dying because of how much pain it is. And there is someone right now, there are probably hundreds, if not thousands of devs right now that their sole job is still upgrading from React 16 to 18. Like, it's painful. You know that's someone's job. And I bet you there's someone in this chat right now that's doing it. And it just is emotionally bruising. Yeah, been there. Yeah, it hurts. The inherited legacy project with my new role, all in .NET 4.5. Got my first job when React 18 wasn't released. Had to go through the mess of upgrading a server components without a seniors even knowing how it's fully functioning. That doesn't even make any sense. Anyways, there was also differences with how legacy sets in. The way state propagates itself in React makes it very hard to separate logic from view. So all this use memo, use callback, use context stuff mixes with flux, redux, remix, etc. It's easier to rewrite everything continuously. Yeah, it is. It's very hard to upgrade, very easy to rewrite. It's tough. We're on Next.js 12, and I think the current version is 15. And I've never wanted to figuratively Kermit sewer slide more than I do now facing the upgrade. Yeah, I mean, it's just... it's just, that's the thing. This is why I'm so against these things. And I know a lot of times people think I'm just memeing or I'm just like JavaScript sucks because I sit in some sort of ivory tower. I'm not saying those things. I'm just saying I've had to do a lot of updating of dumb libraries, and it's very, very emotionally painful. And so, yes, I can see why web components are good. I like the idea of web components because they stick around forever. I like that. It makes me feel good on the inside. Just knowing that nice little assurance, okay? Remember, just don't upgrade. Sometimes that's not a choice. Sometimes that's just like not a choice. Like you don't get to do that because, like node 16 for each loops are like 10x slower than node 18. You can actually have a dramatic memory and CPU win by upgrading node on your endpoints. And luckily, Node is actually a pretty easy upgrade, right? You're not going to get nearly owned as you will with something else. And so sometimes these changes are because you actually need the performance. Or perhaps giant vulnerabilities. Where was it? Let's see. Working with our 10-year-old Phoenix plus jQuery app is so much nicer to work on than our large React app. That's crazy. That's a crazy statement. Use Lua instead of JS. Let's see. When all code is written by AI, how are you going to upgrade? Ooh, got him.
I'll be completely honest. This thing was hyped up maybe like a year ago by like Primogen and a bunch of other people.
Let's go. Let's go. Got the mention. Let's go. Oh my gosh. What a nice guy.
It's kind of cooled off since then. But I am honestly thinking about using HTMX and Go.
Let's go. You should.
For a lot of my content in the future. So if you want to stick around on my channel and still learn about TypeScript and Next.js, I will still publish that type of content because I don't want to just completely kill off all my channel. But again, this is more of like a mindset change that's happened to me. I've been coding for almost 10 plus years. And I'm just getting to the point where it's like, I just want to be able to ship code and not worry about Next.js's 50 caching rules or worry about using unstable no store, unstable cache, or another version update with Next.js that's going to break something or change the way we have to do stuff, or React 19 bringing out a new compiler I have to think about and use. It's like, what if I could just put 2 tags on an HTML element, and when you click it, automatically have this button show an indicator, and then when it's done, my Go API sends over HTML, which I can swap out in the front end and achieve 90% of the same functionality that I have seen all throughout my career. Most of the stuff that I've used AngularJS and Angular and React and Vue for.
That is so funny. It's so funny that that just the realization that all I really wanted was you to click something and then something to be shown. And I've been using so much stuff to get this one simple thing. And all of a sudden I realize it ain't all that bad. It actually is pretty easy. By the way, I saw somebody go in all capital letters. Isn't there some drama about HTMX guy who made a copy from some other lib and the dude who just made it a horrible person outside of everything? So HTMX, you're right, is actually a copy of Intercooler.js. The joke is that Carson makes fun of his past self who wrote Intercooler.js and says he stole it from Carson. It's the same author. That's the joke. You know, the problem with inside jokes like that is that some people don't realize that you're being bamboozled. It's actually that's all it is. It's the biggest. He's the biggest troll on Twitter. You know, he stole it from himself. That's the point of the humor is he stole it from himself and removed jQuery. That's like what HTMX is. HTMX1 is intercooler without jQuery. HTMX2 is HTMX1 with ES6 support. Yes, it is literally astronaut meme. But that's the funny part is like that's the part that just makes it so good is that the guy's a memer. And by the way, he's in that video I recommended earlier. I know I forget if I recommended it in this video or in a previous one, but there's this talk by HTMX man who's really, really, really good. And this one right here, by the way, I get to introduce him. But nonetheless, he talks about jokes, and jokes are the one thing you don't joke about. And he's so right about that. Like you really have to think about the jokes you're making, and he's just really into that, and he is just such a good memer, and he is just so good. I thought he was a degenerate like the rest of us, but the guy's a professor and has a PhD. He's like not a dummy. He's a professor up at Montana State University, my alma mater, my old stomping grounds, and he's actually really, really smart. Dude, He's actually really do. I know. And the funniest part is what he teaches up at Montana State is like systems programming, databases, and compilers. And then he makes HTMX on the side, right? Like, it's just like you would not take those things together and then assume what comes out as HTMX. That's what makes it so good. He's not even a classic backend dev. He's like a Linux nerd. And he's just, he made HTMX because he's bored, because he wanted something else. He's trying to save all the young people from going into the industry and losing themselves in JS. He just wants to make something that's different, right? He wants to make something that makes, that just like can give you a different perspective. And he's really good at it, right? He's really good at that. My professor wrote GrugBrain Developer. I would be thrilled. Yeah, he also writes GrugBrain Developer. So if you've never seen GrugBrain.dev, is it GrugBrain.dev? Yeah, he also writes this, and it's just so good. And he's so right about this. The eternal enemy, complexity. Apex predator of Grug is complexity. Complexity bad. Say again. Complexity very bad. Now you say it. Complexity very, very bad. Given choice between complexity or one of the one-on-one against T-Rex, Grug take T-Rex. At least Grug see T-Rex. Like, so good. He is Grug. And it makes perfect sense. Like, this take is perfect. Look, complexity is spirit demon that enters codebase through well-meaning but ultimately very clubbable non-Grug brain developers and project managers who not fear complexity spirit demon or even know about sometime. I love that. I just absolutely love that take. Very clubbable. You get the idea. It's so good because it's so right. Well, I use many words when few do trick. Yeah.
It's literally, here's a form, submit it, process some data, send some data back. Like, that is literally what I've been doing for 10 plus years. And your mileage may vary. Like, if you're on a project that's building like Eraser.io or you're building Excalibur, then yeah, you're going to have to get more into the JavaScript side of things. But for most of what I've built in this industry, and what a lot of people build as well, is literally, here's a form, submit it, process it, send something back. And again,
so true. So dang true. Like, that's most of what the web is just a very fancy looking form. Right? It's just a fancy looking form, and that's it.
And I think we need to start thinking in the mindset of, can we achieve 90% or 95% of the interactivity that our designers ask for or that our business asks for by using like 50% less code or 50% less complexity or 75% less third-party services? Because the more you keep tacking onto this, it's just like a gear cog that you keep adding gears. And the moment one of those gears breaks or becomes deprecated, you end up spending more time trying to update that stuff or swap it out instead of actually shipping functionality.
Incidental complexity is like one of my least favorite aspects of engineering. I spend so much time trying to solve myself being able to solve the problem as opposed to me solving the problem. Like, I end up, like, you end up just wrangling ad infinitum so much, like, just setup, and it just is emotional. It hurts, right? Joe Spolsky, architect astronauts. Yeah, I've heard about this Joel Spolsky fella. He's pretty dang smart. I really like that. The XY problem moment. Well, it's not XY problem, right? For those that don't know the XY problem, it's that you have problem X and you're trying to solve problem X by doing Y, and then Y doesn't work, so you ask how to solve problem Y, and it confuses everybody. So you're solving X incorrectly with Y, but you're asking about Y as opposed to X. This is different. This is more like you need to solve problem X, but to solve problem X, you have to first learn about how Y works. And so you end up fighting and trying to understand why Y even exists. Then once you finally get it, then you're faster at solving X. Right? Then you can actually do that. That flew over my head. It's like, here, XY problem. Is it xyproblem.com? Is it actually that simple? No, it's not. That was so dangerous, by the way. XY problem. I probably should have just Googled it. Right. There you go. The XY problem is a communication problem encountered in help desk, technical support, software engineering, or customer support situation where the question is about an end user's attempted solution X rather than the root problem itself, Y or Y. Oh, whoopsies, I had it backwards, right? But this makes perfect sense. Like when you think about it, how often have you been trying to solve something and you end up solving it a way that's not quite correct? And then you're asking about that problem and you go, oh, shoot, and then someone comes in, they know what's happening. They go, oh, shoot, actually, if you just do this, it's way easier. And you don't even have to do X altogether. Like X doesn't even actually have to exist because this is actually what you want to do. And so it's called the XY problem. So you should study this and you should immediately cure yourself of the XY problem. Because it's very, like most of you probably don't even realize that you do this. I did this. I certainly did this until I formalized why this was happening. And then once you realize what's going on, you're like, oh man, this makes so much more sense. And then it's so much better if you write your question out thinking of this problem.
So that's my talk. Again, don't be scared. I'm still going to make Next.js content. I have like 2 legit projects using Next.js, so I'm not going to just abandon them. Like Project Planner AI, completely written with Next.js. So yeah, I'm not going to just abandon it. But I just wanted to kind of put that idea into your head, especially if you're like a beginner, to have that mindset. Can you achieve the same functionality with using less dependencies, using less memory, using less complexity, less third-party services, less cloud providers, and still achieve what you need? Okay. Have a good day. Happy coding.
Oh, loved it. I absolutely loved it. So Joel Spolsky, I think I'm saying his thing correct. It's Joel on Software. Joel on Software. So shockingly enough, I just read this article. Look at that. Did you see that when I was typing that? There it is. Defense of not invented here syndrome. He actually talks about destroying, find the dependencies and eliminate them. And he talks about doing it. And his reason why is that if it's a core business function, do it yourself no matter what. And that's such a good take. Because that right there is going to make it so that you don't bring in as many dependencies. And the ones that you actually need the functioning from, you build in such a way that solves your problems and only your problems, which is so good because your problems are always going to be somewhat unique, and using a generalized hammer for your problems may work for the first little bit, but you will, like anybody who's been in the software industry long enough knows that as time goes on, it gets harder. It gets harder, and then you all of a sudden you find yourself like adding these weird abstractions on top of the library that you're using to like try to make it work, and then you end up harder, and then you end up having to upgrade. Then you can never upgrade because the thing you're using has abstractions built on top of it to prevent all these problems, and then you've literally created a locked-in horrible situation. Whereas if you can just go, this is our core business, we will not create a dependency here, we will build this one thing ourselves, it will work. And I gave the example when I talked about this of working at Workiva, which is a tax company, in which what we built is we wanted the same thing in our old ActionScript legacy library to appear identical on an iPad in the new JavaScript library. This was in 2012. And so to achieve this, we built our own kerning system. We literally kerned identical to how ActionScript did it on the server in Python to be able to write out canvas instructions. That way, no matter what you're looking at, you can look at it in ActionScript legacy app or in the new one, and the docs are identically created. And that's a huge strategic business value. So instead of relying it on or trying to like make it work in whatever Chrome was using, and then also Firefox, which rendered it differently, which also then Safari rendered it differently, right? Like there's a whole bunch of things that got rendered differently because of JavaScript in early days. It was just like, this is a nightmare. So instead of just writing it ourselves, even though it cost a lot, it literally cost probably $500,000 to $1 million a year for web filings to maintain. It bought so many more engineering time and the ability to make it exactly the way you want it. And I know it was expensive up front, but man, did it pay off. It paid off so dang much. And then it eventually was rewritten in Go and was super hyper efficient. The end. So I have to build all my stuff. Well, that's why I just pointed this. If it's core business function, build it yourself. Like, so for web filings, the obvious core business function was tax documents, which work anywhere and look the same everywhere. That makes sense, right? Like, you wouldn't want to be working on a document, and then if you switch to a browser, it looks completely different, and all of your formatting and everything's effed up, and then it doesn't work, and then people are doing this, like, formatting battle going back and forth. You had to have it so that it actually works. Kerning as in font rendering. Yes, font rendering, kerning. So there you go. It's so refreshing to hear. I've had the same Outlook at work and usually get shut down because there's a library for that. See, I think that there's a library for that / the don't reinvent the wheel is a very bad take. Because very bad, what I mean by it's very bad is that it ends up causing this mentality where there is no such thing as innovation, or innovation is for somebody else. You are literally just like a pipe gluer. And it's almost on dry level badness. Yeah, I mean, there's good ideas about dry, but you should invent the wheel. When you need to invent the wheel, invent a better wheel. Okay? Because if we didn't reinvent wheels, we'd still be on those oldie time wooden, it's actual stone wheels. Like at some point, reinventing the wheel actually has been really good. Right? It's actually really good to reinvent the wheel. We should all reinvent the wheel. Like, I'm happy that, like, imagine if Formula One racing was like, whoa, we can't be reinventing wheels here, buddy, okay? We need to, come on, let's get some off-the-shelf, consumer-grade wheels. They'd be like flipping cars left and right. It would be crazy. Yeah, it would just be out of control. It would just be out of control. There is no value in a company that if you don't reinvent the wheel. That's true. I think there is a lot of value in a company. If you aren't making something, you are just gluing things together, which means you actually have no strategic moat. You've not built anything. You've just simply tied things together. And somebody who's a better programmer than you will be able to write it together faster, right? They'll be able to do it. That is. To be fair, tires are not invented by teams, but provided in Formula in F1. Yeah, but they had to reinvent it, right? They still had to create a different tire. So there you go. Anyways, web dev code, amazing. Absolutely, just absolutely amazing. Please, you got to go subscribe. Go subscribe immediately. Go as fast as you can. Absolutely amazing. Go get them. This was a super good video. I really liked the take, and I really liked it that it showed. I really love watching that kind of time period in someone's life. Because if you've been programming long enough, you recognize the same thing. And it just feels amazing. You subscribe? Oh, I'm not even subscribed. Boom. Doing it. Did it. Done it.
So if you all follow me on Twitter, you might have...
And liked it as well. This was very, very good. This is such a good one. In fact, I liked it so much, I'll even get this one on Twitter. Okay? Done. Cody rocks. Cody does rock. All right, hey, the name. Wait, what? The name is the prime. The name is the prime. What the hell's my name? I'm on the wrong side of the screen. It's bamboozling me. Oh, crap. I'm moving stuff. Who am I? Who am I?